All right, let's just talk about the inverse of a matrix. Now, the inverse of a 2 by 2 matrix, let A be the matrix A, B, C, D. Then the inverse of A denoted A superscript minus 1. A inverse is equal to 1 over the determinant of A times the adjoint of A. All right, so how do we get the adjoint matrix? We're going to interchange, for a 2 by 2 matrix, we're going to interchange the leading diagonal elements. The other two diagonal elements stay where they are, but their signs change. Example 33. All right, example 33 is asking us to find the inverse of the matrix A. Now, A inverse is equal to 1 over the determinant of A, adjoint A. Now, the determinant of A would be 3 times 5, 15, minus 4 times 2, which is 8. The determinant is 7. So A inverse would be equal to 1 over 7. And the adjoint, you're going to switch around the leading diagonal elements. So 5 and 3 will switch them around. The other two elements stay where they are, but their signs change. All right, now I can further write this as to say A inverse is equal to 5 over 7. Multiplying by 1 over 7 is the same as saying divide by 7, minus 4 over 7, minus 2 over 7, 3 over 7. That's A inverse. Given that A is the matrix 1, 2, 2, minus 1, we're to find the inverse of A. A inverse is equal to 1, the determinant of A, times adjoint A. Now, the determinant of A would be 2 times minus 2. 1 times minus 2 is minus 2. Minus 1 times 2, which is 2. The answer here is minus 4. So A inverse would be minus 1 over 4, minus 2, 1, minus 1, minus 2. All right, so this becomes A inverse is negative times a negative is a positive 1/2, positive 1/4, positive 1/2, and minus 1/4. All right, this says cofactor of a 3 by 3 matrix. The cofactor of an element of a matrix is found as follows. You're going to ignore the row or column containing the element and find the determinant of the remaining matrix. Now, given the cofactor of a cofactor, give the cofactor a positive or negative sign depending on the position of the element in the matrix. For a 3 by 3 matrix, the pattern of signs is positive, negative, positive, negative, positive, negative, positive, negative, positive. All right, so example 35 says, find the matrix of cofactor of this matrix here. So the first thing we need to do is to find the cofactor of every element. So let's find the cofactor of this one here, which is the first which is the element in the first row and in the first column. All right, so we're gonna ignore this and ignore all those elements and find the determinant of the remainder. So this would be the cofactor of the first element. sorry, the cofactor of the element in row 1, column 1 is the determinant of 3, 1, 2, 4, and determinant here is 3 4s 12 minus 2 1s 2. The determinant is 10, or the cofactor element of that one is 10. Let's find the cofactor element of let's find the cofactor element of the 2. The cofactor element of the element which is at the position of in the first row, at the first row, second column, first row, second column. That's the 2. So it's going to be the determinant of minus 1, 1, 2, 4. The determinant here is minus 4, minus 2, which is minus 6. The determinant of the element that is at the first row, third column. So it's going to be the determinant of minus 1, 1, 3, 1. So the determinant here is minus 1, minus 3, which is minus 4. Second row, first column. This is going to be the determinant of 2, 1, 1, 4. And the determinant here is 2 4 is 8, minus 1 by 1, 1, which is 7. Middle row, middle column, it's going to be determinant of 1, 1, 1, 4, which is equal to 1 times 4, 4, minus 1 times 1. This gives me 3. There's going to be the determinant of 1, 1, 2, 1, 1, minus 2, minus 1. Third, let's go to the third row, first column. So this is going to be determinant of 2, 3, 2, 3, 1, 2, which is 4, minus 3, which is 1. Determinant of 1, minus 1, 1, 2. And the determinant here is 2 minus 1, which is 3. Lastly, here, so the determinant is 3 minus minus 2. And this will give me 5. So I have all the elements. I just need the correct signs. So the matrix of cofactor, following the sign convention, positive, negative, positive. So in my 3 elements, this is positive 10, minus 6, positive, negative, positive, positive, minus 4. All right, then negative, following the sign convention, is negative, positive, negative for the second row. So second row, negative 7, positive 3, minus, 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 minus 1. Fourth row, positive, negative, positive. So it's positive 1, negative 3, positive 5. So finally, what this will look like is 10, 6, minus 4, minus 7, 3, 1, 1, minus 3, 5, and this would be my matrix of cofactors. All right, so for now, we just need to practice how to derive the matrix of cofactors. As we progress a little further, we'll see the usefulness of it. This says find the matrix of cofactors of this matrix here. So I need my elements A1, 1, A1, 2, A1, 3, A2, 1, A2, 2, A3, 3, sorry, A2, 3, 2, 3. So that's second row, third. So let's go and get them. The cofactor for the first element, the element in first row, first column is the determinant of 0, 1, minus 1, 4. This is equal to 0 minus 1, which is 1. This would be the determinant of, for cover this and this. So it's a determinant of 1, 3, the determinant of 1, 3, minus 1, 4, 1, 3, minus 1, 4, 4, minus 3, 7. Third one is going to be the determinant of 1, 3, 0, 1, 1, minus 0, 1. Second row, all right. So it's just the 2, 2, 1, 4. So this becomes the determinant of 2, 2, 1, 4, 8, minus 2, 6. So the cofactor element is 6. This one here, all right, minus 1, 3, 2, 4. Minus 1, 3, 2, 4. And the determinant would be minus 4, minus 6, which is minus 10. All right, this one here, so it's going to be the determinant of minus 1, 2, 3, 1, minus 1, minus 6, minus 7. So next we have A3, 1, A3, 2, A3, 3. And we're learning how to find the matrix of cofactor, 3, 3. So this would be the determinant of 2, 0, 2, minus 1, which would be minus 2, minus 0, minus 2. this would be, all right, so it's minus 1, 1, 2, minus 1. So this is determinant of minus 1, 1, 2, minus 1. So this would be 1 minus 2, which is minus 1. This is the determinant of minus 1, 1, 2, 0, 0, minus 2, which is minus 2. And now the matrix of cofactor, utilizing the sign convention. It's the sign convention is positive, negative, positive. So my matrix of cofactor, positive 1, negative 7, positive 1, negative 6, positive negative 10, which is negative 10, negative negative 7, which is positive 7, then positive minus 2, which is minus 2, negative minus 1, which is 1, and positive minus 2, which is minus 2. This would be my matrix of cofactor. All right, so next you're going to get a chance to see how we can use this matrix. So this says inverse of a 3 by 3 matrix. This says A inverse is equal to 1 over the determinant times adjoint A, where adjoint A or adjoint A is the matrix of the cofactor transpose. So adjoint A is the transpose of the matrix of cofactor. So the adjoint is the transpose of the matrix of cofactor. So let's go for the inverse of all right. Let's go for example 37. It says find the inverse of A. So we're going to need, for inverse, we're going to need determinant and we're going to need adjoint A. So since we're going to need the determinant, let's start out with the determinant of A. The determinant of A is 1, 2, 2, 1, minus 1, minus 0. The determinant of 2, 1, 1 minus 1 plus minus 1, the determinant of 2, 1, 2, 2. So this is 1 minus 2 minus 2. All right, this goes because you have multiplied something by 0, you're going to get back 0. So this gone, minus 1. And then we have what? 4 minus 2. So this here is minus 4 minus 2, which is minus 6. So the determinant is minus 6. Let us then obtain the matrix of cofactor. So I need the cofactor elements. All right, so I need the elements of the matrix of cofactor. A1, 1, A1, 2, A1, 3, A2, 1, A2, 2, A2, 3, A3, 1, A3, 2, A3, 3, 3. All right, let's get all of them. All right, so this becomes the determinant of, we actually found this determinant already, you know. Determinant of 2, 2, 1, minus 1, which we actually found already. And the determinant here was minus 4. The second one was actually 0. So it's 0, and then inside bracket we have 2, 1, 1, minus 1. And because we have a 0 in front, it's going to come out of 0. Third one, we have the determinant of 2, 1, 2, 2, and we worked this out already. And the determinant here would be 4 minus 2, which is 2. So the determinant here is 2. So let's go to the second row. All right, so this becomes the determinant of 0, 2, minus 1, minus 1. That's 0 minus minus 2, which is 2. All right. All right, so it's 1 minus 1 minus 1. This becomes the determinant of 1, 1, minus 1, minus 1. That becomes minus 1, minus, minus 1, which is 0. If I block here and here, 1, 0, 1, 2. So this becomes the determinant of 1, 1, 1, 0, 1, 2. This is 2 minus 0, which is 2. Third one, 0, 2, 0, 2, minus 1, 1. Double check. This is 0 minus minus 2, which is 2. All right, set. That is for blockout here and here. 1, 2, minus 1, 1. 1, 2, minus 1, 1. So let's double check. So this is 1 minus minus 2, 3. Lastly, 1, 2, 0, 2. This is 2 minus 0, and we get 2. So let's go for the matrix of cofactor, including considering also the signs, positive, negative, positive. So positive minus 4 is minus 4, negative 0 is still 0, plus 2. Negative 2, 0, positive 0, negative 2. Positive 2, minus 3, and then minus 2. So this is the matrix of cofactor. All right, so next I need the adjoint. The adjoint is the transpose of the matrix. So adjoint A, all right, we can just go straight into it. So A inverse is 1 over the determinant of A, adjoint A. So this is minus 1 over 6. Now adjoint A is the transpose of the cofactor matrix. So it's minus 4, 0, 2, minus 2, 0, minus 2, 2, minus 3, minus 2. All right, so technically that is A inverse. If we want, we could negative times the negatives are positive 2/3, positive 1/3, negative 1/3, 0, 0, positive 1/2, negative 1/3, positive 1/3, negative, negative, no positive again, 1/3. So this would be the matrix A inverse. Let's see what's coming next. All right, so essentially, next I want us to do it again. All right, so let's do it again. A inverse, we need for A inverse is equal to 1 over the determinant of A times adjoint A. Now, adjoint A is the transpose of the matrix of cofactor. So let's start by finding the determinant of A. The determinant of A, 3, 2, 0, 2, 1, minus 1, 4, 1, 2, 1, plus 1, 4, 1, 2, 0. This is equal to 3 into 2 minus 0 into 4 minus 2 into 0 minus 2. This is 6 minus 2 minus 2. So it looks as if the determinant here is 2. Let's get the elements for the um, matrix of cofactor. A1, 1, A1, 2, A1, 3, A2, 1, A2, 2, A2, 3, A3, 1, A3, 2, A3, 3. All right, those are all of them. The first one is the coefficient of 2, 0, 2, 1, which is 2 minus 0, which is 2. The coefficient of 4, 1, 2, 1, 4 minus 2, which is also 2. The coefficient of 4, 1, 2, 0, 0 minus 2, which is minus 2. All right. 1, 0, 1, 1. 1 minus 0, 1. 3, 1, 1, 1. 3, 1, 1, 1. 3 minus 1, 2. 3, 1, 1, 0. 1, 2, 1, 2. 3, 4, 1, 2. 6 minus 4, 2. Lastly, 3, 4, 1, 2. 3, 4, 1, 2. Same thing as before. So this is 2. All right, so our matrix of cofactor, take into account sign convention, 2 minus 2 minus 2 minus 1, 2 minus minus 1, which is 1, 0 minus 2 2. So this is the matrix of cofactor. So A inverse, 1 over the determinant, which is 2. Then adjoint. The adjoint matrix is the transpose of the matrix of cofactor. So it's 2 minus 2 minus 2, 1 minus 1, 2, 1, 0 minus 2, 2. And so if I want to know, I could say that this is 1 minus a half, 0 minus 1, a half, minus 1, 1, minus 1, minus 1, a half, 1. All right, and that would be my inverse matrix. All right, let's stop here.